experiment. The corneas of anesthetic grafts were irradiated with ultraviolet light of 5 different wavelengths at various doses. During irradiation, diluted saline solution was dropped onto the cornea to prevent the cornea from drying out. Corneal damage was assessed by minor rings, irregularity, and fluorescent staining. The minor ring is the reflection of light source of the corneal surface. If the corneal surface is smooth, a circle-like scotch is produced by each clear dot. On the other hand, if the corneal surface is rough, the light source does become unclear, and the shape of the surface becomes irregular, as seen in spot 2 or 3. Fluorescent staining is a technique that uses excitation light to visualize the fluorescent accumulated in areas of corneal epithelial defect. And condition called structural punctate keratitis, in which corneal epithelial cells are detached one by one. A dot-like luminescence is observed as seen in spot 1, that more cells detach in an area, resulting in corneal erosions as seen in spot 2 or 3. From the results of miring and fluorescent staining, we define the values ROAL and NOAL for each wavelength we examined. ROAL is the minimum dose at which corneal damage was observed, and NOAL is the maximum dose at which no damage was observed. In other words, the tear wave caused by HGIH are assumed to exist between ROAL and NOAL. The results of our experiments with rats indicates that Far-UVC is extremely less hazardous to the cornea than previously thought. So currently, the tear wave of 222 nanometer Far-UVC has been raised from 22 to about 160 millijoule per square centimeter. Okay. So why is Far-UVC less hazardous to the cornea? So this is because Far-UVC has extremely low penetration depth into the tissues. CPDs produced when adjacent purifying gene in DNA are irradiated with ultraviolet light. So we use CPD as an indicator to observe penetration depth of UV light with different wavelengths in the tissues. As shown here, 2007 and 222 nanometer Far-UVC penetrate only to the outermost layer of corneal epithelium. So let me explain a little about corneal turnover. Corneal turnover is described by XYZ theory. The theory proposes that if the differentiation and recuperation of cells at the base of the corneal epithelium towards the superficial layer is expressed as X, the supply of new basal cells from stem cells as Y, and the shedding of cells from the superficial layer as Z. The equation X plus Y equals Z is established. The corneal epithelial layer is replaced in 7 to 14 days in humans. It is assumed that Far-UVC is less hazardous to the cornea because it only penetrates to the outermost layer of the corneal epithelium, which is quickly shed in the physiological turnover cycle. Since the cells that compose the corneal epithelium are differentiated and recuperated from basal cells, it is important that stem cells, the source of basal cells, are not injured in order to maintain homeostasis and their normal turnover cycle of the corneal epithelium. Therefore, we investigated the penetration depth of 222 nanometer Far-UVC in the corneal leaflets, when the stem cells of the corneal epithelium are known to be localized at its basal region. These are H&E stained and image-stained image of thick eyes obtained from slaughterhouse, and CPD positive cells are observed only in the superficial layers of the corneal limbus. In other words, 222 nanometer Far-UVC does not reach the basal area of corneal limbus where stem cells are located. Therefore, corneal epithelial turnover is not expected to be affected by Far-UVC radiation. However, in our previous studies, we used animals and anesthesia or postmortem. During irradiation of anesthetized animals, a diluted saline solution was dropped onto the cornea to prevent it from drying out. This means that irradiation was performed in the absence of tear layer on the corneal surface. So the purpose of our experiment is to determine if the presence of tear layer affects 222 nanometer Far-UVC penetration depth to the rat cornea. First, we determine the optimal irradiation dose to investigate the effect of tear layer. 6 weeks old male ST rats were irradiated with 222 nanometer Far-UVC. The irradiation dose is as shown here. So the left panel shows rats without irradiation. They were not anesthetized and put in special holding box that were just so that only the head was out of the bag. And on the right side is rat and the irradiation without anesthesia. Far-UVC is irradiated as vertical as possible to the cornea. Regardless of irradiation, the rats rarely blinked. Immediately after irradiation, the eyes were removed and fixed, and immunostaining was performed and spark injection prepared. Here, we define the positive cells observed dose 50, PCOD 50, as irradiation dose at which CPD positive cells were observed in half of the examined corneas. For example, if immunostaining is performed on 6 corneas, and 3 corneas are observed to have CPD positive cells, the irradiation dose to that cornea is PCOD 50. Immunostaining results are shown. CPD positive cells were observed in all corneas at irradiation doses of 10 mg/cm or higher. We decreased the irradiation dose and decided that 3 mg/cm was the PCOD 50 because half of the cornea showed CPD positive cells. Next, we performed Far-UVC irradiation on corneas with different surface conditions. In the physiological condition, as already indicated, irradiation is performed on anesthetized rats, so tear layers are existing on the surface of the cornea. In the saline-covered condition, the corneal surface is covered with diluted saline instead of the tear layer. In dry condition, the corneal surface is dry because tear layer are absorbed by surgical sponge in anesthetized rats. The left panel shows the physiological condition, the middle panel shows the saline-covered condition, and the right panel shows the dry condition. Interestingly, PCOD 50 was 3 mg/cm and CPD was observed only in the outermost layer of the cornea in all 3 conditions. This means that most 222 nanometer Far-UVC will penetrate that tear layer. Unfortunately, the tear layer is not expected to have protective effect on corneal epithelium in rat. In human, previous presentation in this session and past study reported that about over 85% of 222 nanometer Far-UVC can penetrate tear layer. On the other hand, it is important to note that this is an in vitro study. Human tear layer has a 3-layer structure. A mucin layer adjacent to the corneal epithelium, and aqueous layer and lipid layer at the surface. In little studies, the layer do not maintain this three-layer structure. Transmittance of 22 nanometer 5UVC to the layer maintained in three layers, and the effect of 22 nanometer 5UVC on the layer structure and composition of the tier layer is unknown. Another important thing to note is that our study was on rat cornea, and we do not know if the structure and composition of rat tier layer is the same as that of humans. As shown in the previous movie, rats, unlike human, rarely blink. Humans are said to blink about 20 times per minute. On the other hand, rats blink only once per minute. This is the perspective that tier layer may have a different composition and structure from human tier layer and may be more resistant to dryness. In other words, the effect of Far-UVC on human tier layer in vivo remains to be examined. The conclusions. The tier layer does not affect the penetration depth of 222 nanometer Far-UVC to rat cornea experiment. However, that's differ from human in some aspects, such as their extremely low blinking rate, and the composition and structure of the tier layer may also differ from those of humans. So, influence of 222 nanometer Far-UVC against the human tier layer still needs to be examined. Thank you.